So we were discussing about unit and dimension. So unit we have understood. So there are many quantities there are many quantities in which we learn in physics, physical quantities and chemical quantities. But there are some fundamental quantities, and fundamental quantities are those quantities which are independent of other quantities. And there is one derived quantities. Derived quantities are those quantities which can be expressed in terms of fundamental quantities. For example, meter. Meter is a distance. Meter is a unit of distance. Like we are going to measure distance in the terms of meter. So meter is a fundamental quantities. Meter is independent of any other quantities. But if we are going to measure velocity, then it is meter per second. So velocity is meter per second. So velocity is a derived quantity which is expressed in terms of two other physical independent quantities, that is fundamental quantities, that is meter and second. So there are some physical quantities who are totally independent of each other. There are seven fundamental quantities. I will write those seven fundamental quantities. They are like mass, length, time, temperature, fifth is current, and the sixth is luminous intensity, and seventh is amount of substance. So these are seven fundamental quantities which are completely independent of each other. And what is the unit of these fundamental quantities? Mass is expressed in terms of m. Length is expressed in terms of L. Time is expressed in terms of T. Temperature is expressed in terms of Kelvin, which is a unit of temperature, Kelvin. Current we measure in terms of ampere. Luminous intensity is measured in terms of candela, and amounts of substance is measured in terms of mole. All these things, don't worry, we are going to learn slowly. So these are seven fundamental quantities, and all the quantities in the world, they are derived from these fundamental quantities. So these quantities are very important, and any quantity can be written in terms of these fundamental quantities. Like uh, there's mass. Like if we are going to write acceleration, what is acceleration? Acceleration is uh, change in velocity, rate of change of velocity with respect to time, that is acceleration. So acceleration can be written as delta v by delta t, and v is what? Distance per second. So that is L divided by t, and that is rate of change of velocity is acceleration. So this is t. So this will be written in terms of lt minus 2. So everything can be written in terms of these fundamental quantities. And what are these fundamental quantities? Acceleration. Acceleration is written as lt minus 2. And similarly, how velocity was written? Velocity was distance by time. Distance is expressed in terms of length time is expressed in terms of time, distance by time. So obviously it is in the denominator side, so it is L T minus 1. Any dimension is written in terms of a square bracket, because this is formatically with formula it may not be correct, but dimensionally it is written in a square bracket. Any dimension if you are going to write, it will be written in a square bracket. Later also we will see. So I think that this is clear. If you want to note down, then you can note down the seven fundamental quantities, and we have written acceleration in terms of fundamental quantity. Also, we have written velocity in terms of fundamental quantity. Now, coming to another, also, yeah, what is the dimension? Uh, that was the term in which dimension was written, but dimension is what? Dimension is basically the exponent in which a derived quantity is written in the terms of physical quantity. Uh, like what we have written for velocity, it was L T minus 1. So basically, what is dimension? This is dimension. L dimension is, sorry, it's not 0, it's 1. So this is power, this is the power, this is the exponent of any fundamental quantities, that is called dimension. So what is the dimension of velocity? Dimension of velocity is length to the power 1 and temperature to the power minus 1. So these two are the dimensions in the form of length and time. While there are other fundamental quantities, this is only two fundamental quantities, and other all five fundamental quantities are raised to the power 0, that is 1. So velocity is written in terms of those two fundamental quantities. uh, Length is to the power 1 and temperature is to the power minus 1. These two are only the called the dimensions. Rest other dimensions of the physical fundamental quantities are 0. So this is called dimension. Okay, I think that I am pretty much clear. Also, if you write in terms of acceleration, it is L T minus 2. So what is the dimension of acceleration? This is L to the power 1, T to the power minus 2. So length to the power 1 is the dimension and temperature to the power minus 2 is the dimension. So this is called dimension. Okay, I think now I am pretty much clear. Also, whatever formula which we write in physics, they should be homogeneous. Homogeneous means the left hand side and right hand side, both sides should be dimensionally correct. Suppose there are many formulas you might have read in class 10th also, motions in one direction, uniform motions in one direction. So I think you must be remembering V plus E equal to U plus AT is understood. So there are three different terms. Velocity, U is initial velocity, A is acceleration, T is time. So this for all these formulas should be homogeneous. Now we consider V. V is distance upon time. This is L T minus 1. Distance by time, L by T, that will be written in the terms of LT minus 1. Understood? U also, that is also velocity. So it will be also written in terms of LT minus 1. And acceleration, earlier we have learned that the value of acceleration is L T minus 2 into T is time. So it will be T to the power 1. So you can see that all terms are homogeneous. So all the formula in the physics They should be homogeneous. This is LT minus 1, U is also LT minus 1, AT is also LT minus 2 and plus 1, that is LT minus 1. So I think any formula you can write. This is V plus UT, V square equal to U square plus 2AS. Any other uniform motion formula you can apply. The fundamental quantities must be homogeneous. So in this way also we can check whether formula of any physics relation are okay or not. Now dimensions are very useful. Dimensions, so what I told you, that those are the power of fundamental quantities, they are called dimensions. Now dimensions, there are many use of these dimensions. By the means of dimensions we can uh, convert convert one from one unit to another unit. This way we can convert from one unit to another unit, like if somebody must be knowing that what is the unit of joule. Joule, 1 joule is how much erg, 1 Newton is how much dyne. So there are first of all, I think that I should make you learn that there are several other systems in which units are measured. Three important systems are FPS. This is British systems. British systems are measured in terms of, this is foot, pound, second. Distance is measured in the terms of foot, and weight is uh, measured in terms of pound, and time is second. Also, there is one uh, CGS CGS system. CGS system, distance is measured in terms of centimeter, weight is measured in terms of grams, and time is also measured in terms of second. Also, there is MKS system, which is called SI system. MKS. This is a very important system. This is System International. This is US system. MKS. M is meter, K is kilogram, S is second. So these, there are three or maybe there are several other systems in which different physical quantities are measured. So these three are famous system in which physical quantities are measured. So suppose, what is the use of dimensions? Suppose we are going to convert from one unit to another unit. I think you might be knowing that pressure. What is the unit of pressure in SI system? Pascal. And what is pressure? Pressure is force per unit area. And what is the dimension of force? Force is mass into acceleration. Mass is m. You will be understanding by the second law of motion. Force is mass into acceleration, and acceleration also we have read is mlt minus 2, and area is l square, that is l square. So pressure comes in, if we will write in simplify it, then it comes to be m l minus 1 t minus 2. So dimension of pressure is this. So suppose we want to convert uh, SI system to CGS system. CGS system, the unit of pressure is CGS pressure. So how we are going to convert? So there is a way. Suppose there is 1 Pascal, 1 Pascal, 1 Pascal. This must be, that is the dimensional formula. So Pascal is SI. So meter, one meter into 1 kg. M is mass, 1 kg is this 1 meter to the power minus 1. Time is same, second to the power minus 2. ठीक है. I have 1 CGS pressure. What may it may be there may be some other unit also. So CGS pressure, this may be written in terms of CGS unit. So CGS unit is kg is written in terms of grams. So 10 to the power, so 1 kg, 1 grams, 1 meter, 1 centimeter to the power minus 1 into second to the power minus 2. Now we are going to divide 1 Pascal. This equation we are going to divide. So 1 Pascal by 1 CGS pressure. This must be equal to 1 kg is 10 to the power 3 grams. 1 meter is 10 to the power meter milli centi decimeter. 1 meter is 10 to the power minus 2. 10 to the power 2 centimeter. Okay. Power minus 1 into second is minus 2. Second is almost same, so second may be cut. 1 grams, 1 centimeter, power minus 1 into second. Now we cut it. Then gram, centimeter, second, cross. This is 10 to the power minus 2. What it comes? 10 to the power 3 into 10 square to the power minus 1, that is 10 to the power minus 2, that is 1 by 10 square. So it comes out to 10. So we can say that 1 Pascal is equivalent to 10 CGS pressure. 10 CGS pressure. So this way we can convert from one system to another system of any quantity. So I think that it is very much clear. This way there are several other quantities also which we can convert. Understood? We can take another example. Suppose we are going to change force into dyne. Force is the SI unit of sorry, Newton is the SI unit of force, and dyne is the SI unit of CGS system force. So suppose we have to convert Newton into dyne, then what it will be? First of all, we can write the dimensions of force, that is M mass into acceleration, LT minus 2. We have already understood. Okay, so we are going to write 1 Newton. 1 Newton is 1 kg, 1 kg ka power 1 into length is meter, 1 meter to the power 1 into second to the power 1 to the power minus 2. Understood? And 1 dyne, that is CGS system. This is equal to 1 gram into 1 centimeter into second to the power minus 2. Understood? Now once again, if we are going to divide, then Listen, this is 1 kg, this is 1 gram. So 1 kg has to be expressed in terms of 1 grams. Then it comes out to be, suppose 1 Newton equal to 10 to the power 3 grams to the power 1 into 100 centimeter, 10 to the power 2 centimeter to the power 1 into second, 1 second to the power minus 2. Now dividing into, this is dyne. 1 gram into 1 centimeter into second minus 2. Now once again we divide them. Once again if divide, then obviously if dimensions are same, then all these things will be got cut, and only the quantities will be remaining. So it comes out to be 1000 into 10 to the power 2, and all these things will be got cut. So 1 dyne by, sorry, 1 Newton by 1 dyne equal to now. So 1 Newton will be 10 to the power 5 dyne. So I think that you have understood that this MKA system, that is Systeme International SI system, has been converted into CGA system. And what has been converted? This is the force which has been converted into dyne. So this is conversion factor which is determined by the means of dimensions. So this is also a very important use. Now I think that I'm going to delete it. Also there is one another unit of this dimensions, that if we know that there is a physical quantity, and which are the factors on which it is depending, then in that way we can determine that what is the formula, of that particular physical quantity. Suppose if there is a pendulum, and we know that how pendulum is going to, the time period of pendulum, how is going to depend on other factors. So when we learn oscillation, that time also we will learn. Also it is written that time period of any pendulum depends upon length. It may depend upon length, mass, and acceleration due to gravity. So suppose this is the another use of your dimensions. Suppose there is time period, and this is proportional, means it depends upon mass. No, suppose it depends upon mass and length of the pendulum, and also g. G means acceleration due to gravity. So suppose if we know that time period of a pendulum depends upon these factors, mass, length, and acceleration due to gravity, so we are required to create a formula that in which way it is depending upon these three factors. So this is also a use of dimensions, uh, in which we can correlate the formula. Now coming to the how we are going to create the formula for time period of a pendulum. Time, what is the dimension of time? This is m to the power 0, l to the power 0, t to the power 1. This may be the formula. Obviously this is the formula, no? This is 1 1, and time is t to the power 1. Here, what is m? Suppose m to the power a. Suppose it depends in the forms of some exponential power. M to the power a, l to the power b, and g to the power c. Suppose, okay. Then how we are going to check it? This is m to the power a, length is l to the power b, into l, g is acceleration due to gravity, it is l to the power c, t to the power minus 2c, lt minus 1, lt minus 2. So this comes to m to the power a, l to the power b plus c, and t to the power minus 2c. Now this has been written in terms of fundamental quantities. Now we can equate a is, now in this we can equate, no, m to the power 0, l to the power 0, t to the power 1. Then in this way, what is this? A to the power a is 0, and what is b plus minus 2c equal to 1, means c equal to minus half, and b plus c equal to 0. This means b equal to minus c, it's plus half. So this way we have determined what will be the power of a, b, and c. So we can put in this formula m to the power a is 0, l is l to the power b is half, and this is acceleration due to gravity, to the power c is minus half. So understood, this is time period. So time period, that is so time period comes out to be, suppose it is proportional, then it may be constant k under root l divided by under root g. So time period is k under root l by g. So when we learn the oscillation, that time we understand that this is k is 2 pi, t equal to 2 pi under root l by g. So this way what we have learned, that if we know that what are the factors in which time periods depend, then we can derive the formula for that particular physical quantity. This way we knew that time period may depend upon mass, length, and acceleration due to gravity. So what will be the formula? So by the means of dimensions, we have derived that the formula is t equal to k under root l by g. But k is a physical constant. We can derive that what may be the formula, but this is k constant. The value of k comes out to be 2 pi. That we will understand later on. So in this way we can understand that in what way the parameters, the other quantities depending on dimensions. So this was the, this also there is a limit of on this dependency. This formula applies only when the dependency of the other factors, that is mass, length, and acceleration due to gravity, in multiplication form. So this is the limitation of this dimensional accuracy. Also, we cannot determine that what is the constant k. So these two are the limitation of this deducing relations among the physical quantity by the means of dimensions. We can only derive that what may be the power of different other factors, but we cannot derive that what is the exact constant, what is the exact, and it should be in the forms of only multiplication. If there is factors are written in the terms of plus or minus, then this formula will not work. So I think we have covered unit and dimensions chapter. I think that it will be advantageous for all other people also. I will post this, and I request you all to please subscribe to my channel Learn Physics with Love. This is my first video, and it may be that my first video will not be that interesting and not, it may be informative, but it may not be expressed in a very good manner. But I'm very much sure that I will try to teach you in such a way that you are going to excel in your education, whether it is 11th, whether it is 12th, or whether it is NEET or advanced or JEE physics. Also, we'll go through different problems also. So thank you very much.